Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2 for Lab Assignment Electronic Device and Circuits. Our project is Hari Raya Blinking Lights. So, this is our team. My name is Sharifah Sakinah Binti Syed Abdul Hamid. My matric number is 2027X6. And this is my partner, Sarafina Nadhia Abdul Malik. Her matric number is 2026X6. So here is our objectives for this lab assignment. First, we want to create an analysis Hari Raya blinking light using multisim. Second, we want to implement bipolar junction transistor BJT on the circuit. Let's move to the introduction. This project used for celebration and holiday season ornament, both indoor and outdoor used. And this project ideal for decorating party, home, shop, and seasonal days. In this project, flash 12 LED and can be used to create Hari Raya blinking light decorations. And it contains two stable multivibrators. Stable multivibrators basic configuration. First, switching circuit. Generate non-sinusoidal waveform and two-stage RC coupled amplifier with coupling network. Okay, first, we sketch diagram for our circuit. And this is ensure us to follow our plan for implement the bipolar junction transistor in our multisim. Then we applied our sketch diagram to the multisim. We placed voltage source 9 volt, BC107BP, which is these transistors, 4 capacitors, 12 LEDs, 8 resistors, and 2 oscilloscopes to show the waveform of our circuit. Let's move to the demonstration. I will pass this presentation to Sarafina Nadhia.
Okay, next I will show you the demonstration of our circuit and I will explain the working of the stable multivibrator in our project. Okay, before that, what we know about a stable multivibrator circuit. A stable multivibrator does not remain stable in any two states and the output of the multivibrator continuously change between the two states. When VCC is applied, the collector current of the transistor increase as the collector current depend upon the base current, which is from the formula IC is equal to beta IB. Transistor will act as a switch. When input in BJT is less than 0.7, it will operate in the cut-off region and act as an open circuit. VCE is equal to VCC. When input is higher than 0.7, it will operate in saturation region and act as a short circuit. VCE is equal to 0. Therefore, this is the circuit that we have created in the multisim to create Hari Raya blinking light. We have two set of stable multivibrator circuit, set A and set B, that connected through the same voltage. V1 is equal to 9 volt. Okay, therefore I will explain the working of the set A only because they have the same process of the stable multivibrator circuit. They have same working principle. First of all, we have two identical transistor, NPN transistor, but they have different doping level. Therefore they have different time instant. We have VCC is equal to 9 volt. We have 4 resistor, R1, R2, R3, and R4. R2 and R3 is used for biasing purpose. We have 2 capacitors, C1 and C2. Okay, first of all, the collector of C1 of the Q1 is connected to the base of Q2 through capacitor C1, while the collector of the Q2 transistor Q2 is connected to the base of Q1 through capacitor C2. So, AC coupling is provided through this coupling capacitor of each of these amplifier. First of all, when we assume Q1 is in the on state, the operating point collector of C1 is in the saturation region. Therefore, it will act as a short circuit. The output voltage at the collector The output voltage at the collector Q1 will be ideally equal to 0. VCE is equal to 0 because no output signal is given to the base of Q2. So Q2 will remain in the off state. Therefore, the operating point of Q2 will be in the cut-off region. While these two conditions is satisfied, C1 will get charged through VCC. Therefore, capacitor C1 will be charged to the R2, the biasing purpose. Now, C1 will get charged into the maximum value and the voltage will be applied to the transistor Q2. Hence, when the voltage at the base of Q2 is greater than 0.7 volt, Q2 is in the on condition, so operating point is in the saturation mode. VCE is equal to 0. At that time, the Q1 will be in the off condition and act as a open circuit. VCE is equal to VCC. Therefore, this cycle is repeated in set B to light up the LEDs as the working principle of a stable multivibrator state that a stable multivibrator does not remain stable in any of the two states and the output of the multivibrator continuously change between the two states. Okay. Okay, this is the simulation of our circuit in the multisim. We can look at the LEDs at the R1. It will blinking up first. Next, the LEDs in the R4 will blinking up next. This same is in the set B. The LEDs in the R5 will blinking up first, while the LEDs in the R8 will blinking up next. Okay, next I will explain the waveform in the circuit. Hence, the output voltage and the output waveform are formed by the alternate switching of the transistor Q1 and Q2. The time period of this on-off state depends upon the value of the biasing resistor and the capacitor used. We can look at this graph, this waveform. When the Q1 is in the on condition, Q2 will be off, while when Q1 will in the off condition, Q2 will be in the on condition. This is the waveform that we have get from the oscilloscope in our multisim. This shows that the curve is due to the capacitor C charging. Time period is equal to RC.
So, in conclusion, at the end of our lab assignment, we are able to create a project that applied a working principle that we have learned in our course. We are also able to recognize and understand the operation of BJTS stable multivibrator circuits as we implement it on our circuit. We are able to produce waveform from the oscilloscope. And the objectives of this lab assignment, which is to create and analyze Raya blinking light using multisim and to implement bipolar junction transistor BJT on the circuit, were achieved. That's all for our presentation. Thank you.